My research title, Volcanism, Sedimentation, Potassium Argon, and Palynology Studies of Yayu and Delbi-Moye Basins, Southwestern Plateau of Ethiopia. My name is Dr. Wolela Ahmed. Now I am a consultant geologist. I was assigned to be Senior Exploration Geologist, Senior Licensing Geologist, Division Head, Director of Exploration Manager, part-time lecturer and supervisor for postgraduate students in Addis Ababa University and Addis Ababa Science and Technology University. I have published several articles in international journals, Elsevier Science, Journal of African Earth Science, and Geological Society of Africa selects Wolela's publication, Volcanism, Sedimentation, Potassium Argon, and Palynology Studies of Yayu and Delbi-Moye Basin, Southwestern Plateau of Ethiopia, to be an outstanding contribution by African Earth Science to win the 2040 First Annual Prize for Best Paper Award. Now, Science further selected the author of the above paper to receive Best Researcher Award 2023. Introduction. The Yayu and Delbi-Moye Basin are found in the southwestern plateau of Ethiopia. The north and south and east-west trending parallel, perennial and intermittent streams are controlled by the Gabba and Gibe drainage system. The basin consists of Precambrian basement rocks, tertiary volcanic and sedimentary rock. Only scant information is available about the tertiary volcanic, coal and oil shale bearing sedimentary rocks, potassium age dating, and palynology data on this basin. The present research work possibly gives some highlights about volcanism, sedimentation, potassium argon, palynology of the basins. Figure 1, location map of the studied area. The study area is located in Eastern Africa. Objective of the study. The main aim of the present study are 1. To carry out sedimentation and depositional environment studies on coal and oil shale bearing sedimentary rock. 2. Carry out mineralogical studies on volcanic and sedimentary rock. 3. To carry palynology studies, and 4. To carry potassium age dating on volcanic rocks. Methodology. Volcanic and sedimentary rock samples from boreholes and outcrop were collected for different analysis. 1. Volcanic and sedimentary rock were examined using transmitted light microscope. 2. This microscope was used for palynology study. 3. 6 volcanic samples from the lower and upper basalt in the Yayu and Delbi-Moye Basin collected for potassium age dating. Samples for potassium age dating were initially crushed with a jaw crusher, manganese steel jaw. A fraction of 700 to 500 micron was sieved from the obtained powder used for potassium argon analysis. 13 volcanic samples were collected from Yayu and Delbi-Moye Basin for XRF studies. Major and trace elements have been analyzed by combined with chemical method and X-ray fluorescence procedures, according to Franzini and others, 1972. Background geology. The Yayu and Delbi-Moye Basin consists of Precambrian rocks, tertiary sedimentary rock, and volcanic rock. 1. The Precambrian basement rocks are dominated by biotite cartoozo feldspathic gneiss. Borehole studies confirm that the presence of fracture-oriented parallel, oblique, and perpendicular to the core axis. The fractures are infilled by silica, sulfide, and pyrite. 2. In the Yayu Basin, the lower basalt unconformably overlies the Precambrian basement rock and reach a thickness of 145 meters. The thickness of the lower basalt increased towards the Delbi-Moye Basin. The lower basalt is mainly dominated by plagioclase, pyroxene, olivine, biotite, and opaque minerals. Fractures in the lower basalt are filled by secondary minerals, silica, calcite, zeolite. 3. The coal and oil shale bearing sedimentary rocks are unconformably deposited either on the Precambrian basement rock or on the lower basalt. The sedimentary rock consists of sandstone, siltstone, mudstone, coal, oil shale seams. The sedimentary rocks were deposited in a north-northwest, south-southeast trending gravens and half graben. For the upper basalt, unconformably overlies the sedimentary succession. The unit reached a maximum thickness of 102 and 300 meters in the Yayu and Delbi-Moye Basin, respectively. Fractures are filled by secondary minerals, calcite, iron oxide, and zeolite. Figure 2, geological map of Yayu Basin. Figure 3, litho and chrono stratigraphy section of Yayu Basin. The basin consists of Precambrian basement rock, lower basalt, sedimentary rock, and upper basalt. Figure 4, borehole correlation section of Yayu Basin. Figure 5, geologic map of Delbi-Moye Basin. Figure 6, chrono and lithostratigraph section of Delbi-Moye Basin. The basin consists of intermediate to acidic volcanic, upper basalt, upper sedimentary rock, middle basalt, lower sedimentary rock, and lower basalt. Figure 7, correlation section of borehole Delbi-Moye Basin. The Delbi-Moye Basin sedimentary succession is characterized by 3 cycles: first cycle, second cycle, and third cycle. Figure 8, outcrop section of Yayu Basin. In this photograph, clearly showing that the coal seams and the oil shale seams well exposed in Table stream section. Table 1, palynomorph of Delbi-Moye Basin and Yayu Basin. The assemblage consists of petrified angiosperm, algae, and fungal spores. According to the assemblage, the sedimentary rock ranging from Oligocene to Miocene age. Figure 9. Fracture in basement rock. B. Fracture in lower basalt. C. Calcite filled basalt. D. Fracture in upper basalt. Table 2. Analytical XRF result of representative volcanic rocks in Delbi and Yayu basins. According to silicon oxide versus sodium oxide, potassium oxide, clearly shows that the Delbi-Moye Basin is dominated by theolitic basalt. Table 3, potassium argon age dating result. In this study, the age limit is ranging from 19.98 to 111.19 MA. Summary and conclusion. 1. The Yayu and Delbi-Moye Basin sedimentation are characterized by alluvial fan, offshore lacustrine, shoreline lacustrine, and meandering depositional environments. The palynomorph of the coal and oil shale bearing sedimentary rock indicates that the presence of small algae, fern, fungal spores, pollens of flowering plant. Freshwater algae, Potrococcus bruni, Pedestrium species, Pelopodaceous spores favis, and Pelopodaceous spores afavis, and Phachidimis dedistrixi are common palynomorph in the studied coal and oil shale are indicator of lacustrine environment. The presence of Euphorbicia, Polopicia, Melipoticia species, Dodonia, and Metriatia coordinatis, Rubicinica species, pollen derived from tropical shrub. Sapotica species, Melician species are indicative of humid tropical rainforest conditions. Petrodophyte furnace spores, Dolotripa species, Vorticospores, and fungal spores, Hexonia species are indicative of swamp life and lacustrine conditions. Extensive bioassembly confirms that the age of the coal and oil shale bearing sedimentary rocks are Oligocene-Miocene. The presence of Petroglobulis nigricus is also inconsistent with Oligocene to Miocene. Silicon oxide versus sodium oxide plus potassium oxide XRF data plot indicate that the studied basalt are theolytic in composition. The age dating range from 90.98 to Lower Miocene to 111.90 early Cretaceous age. Further work on the volcanic rock will help to confirm the age of the volcanic rock on the Southwestern Plateau of Ethiopia. Cores are available from the Yayu and Delbi-Moye Basin. Acknowledgements. The International Research Excellence and Best Paper Award are given to outstanding contribution in original research, innovative thinking, quality and impact published work. Science Father plays significant role for selecting of outstanding research papers. I appreciate the work done by Science Father and the International Research Excellence and Best Paper Award. Therefore, I thank Science Father and International Research Excellence and Best Paper Award for selecting my research paper entitled Volcanism, Sedimentation, Potassium Argon Palynology Studies, Yayu and Delbi-Moye Basin, Southwestern Plateau of Ethiopia. I give many thanks being selecting the author of the above paper for Best Researcher Award by Science Father and International Research Excellence and Best Paper Award. Thank you.